All right, so in our last video, we were looking at writing ionic symbols given their names, and now we're going to turn that around and work on writing ionic names from the symbols. So, little different skill set. Some things are going to be easier, some things are going to be tougher. So, the steps, just like before. Step 1, this time around we write the name of the metal, and if it's a multivalent, we'll have to include the charge within brackets as Roman numerals, and we'll see how that works in a moment or two. Most of them won't need brackets and Roman numerals. Second, you write the name of the nonmetal, but the ending has to be changed to IDE, kind of like fluoride. And in your textbook, in the same section as before, you can see the list of some of those endings and how much of the original name gets cut off. So, an example, LIF. So step 1, write the name of the metal. Okay, so that's going to be lithium. And that F is fluorine from the periodic table, but we changed the ending to IDE, so that has to be fluoride. Okay, that's it. That's lithium fluoride. Let's look at the second one. Al2S3. Okay, so now we got some subscripts here, so the question is, what do we do with them? Well, the rule says write the name of the metal. That's aluminum. Aluminum is not one of those multivalents, so we don't need brackets, no Roman numerals. S, the element is sulfur, but the ending changes to ide, so sulfide. And that's it. Let's do another one. MgO. Now, MgO is one of those where when we did the crossover, the ratio simplified, and so we might be wondering, does that mean I got to do something special? No. First step, write the name of the metal. Magnesium. Good. O would have been oxygen, but the ending it now changes to oxide. O-X-I-D-E. Okay, so far this is looking really, really good, because we don't have to do crossover, we don't have to figure out charges. This is working really nice so far. But now let's get into those multivalent ones. So adding multivalent sometimes. So here's a few, some have multivalent, some are not. So let's have a look at the first one. Example 4, CuI. So copper is one of our multivalents. So the first rule says Cu is copper. I realize it's a multivalent, so I'm going to put a bracket, leave some space. I'll fill in the rest of it in a moment. Capital I is iodine, but the ending changed to IDE, so it's iodide. And so now the challenge is figuring out what is the charge on copper. Well, one of the things that we can do is we can look at a periodic table, and when we check the periodic table, we find that iodine is in group 7 over on the right-hand side. And so it's in group 7, needed 1 electron, so it has a charge of -1. So notice I'm filling in the charge above the symbol now. Since iodine was -1, and there's only 1 copper and only 1 iodine, all the charges have to add up to 0, because it's a neutral compound, which means if iodine is -1, copper has to be +1, because that way they'd end up with no subscripts. So that means that our Roman numeral inside the brackets is 1. So copper 1 iodide. Let's look at another one. Fe2O3. So we're going to do the same thing again. Fe is iron. We know it's a multivalent, and O is oxide. You're going to have to memorize which ones are multivalent. Now, the negative ion, the nonmetal, its charge will never change, so you always start there. Oxygen's in group 6, needs 2 electrons, so it's -2. Now, The crossover rule worked perfectly to send this 2 down there. Because of that, we know that the crossover rule had to put this 3 there, which means the charge on iron had to be plus 3. See how that worked? The subscripts came from the crossover rule. Therefore, iron has to be iron 3. Okay, let's have a look at another one. So COF2. Now, cobalt was not on our list. Because of that, there's no bracket, so it's just cobalt. And then F is fluorine, but we changed the ending to IDE, so it's fluoride. That's it. It's not a multivalent, so we don't put a bracket in. If it's not a multivalent, you cannot put a bracket with a number in. So if it's not a multivalent, no brackets. PbCl4. So Pb is lead. Lead is a multivalent, so we put in the bracket. And chlorine changes to chloride. Now all we have to do is figure out what the crossover rule does. Well, that 4 came from the charge on lead, plus 4. It couldn't have been simplified because the only possibilities for lead are plus 2 or plus 4, so we know that lead had to be lead 4. And to double check, the chlorine is in fact -1 because it's in group 7 on the periodic table. All right, so the last one from some examples here. So SN is tin. It is a multivalent, so we put brackets. And O is oxide. Now, at this point, if we were to start with this 2 here and bring it up, we'd be saying, oh, tin must be plus 2. But the better place to start is with the oxygen, because it's the nonmetal. It's -2, and you'll notice there's no number down here. That means that it had to simplify. We had to divide the 2 by 2 to get 1. Since we had to divide the 2 by 2, this time we have to multiply in order to get the charge, plus 4. So the way to check is if we were to have written tin 4 oxide with this simplify to SnO2. Well, let's check it. We're thinking it's tin 4 oxide. Oxygen is -2. Tin 4 is obviously plus 4. The crossover rule says 2 goes down here, a 4 goes down there. But we say, hey, we can simplify this by dividing both sides by 2. And the ones we never have to write, so obviously tin 4 had to be right. So don't be afraid to do a little bit of work on the side, just to make sure you got it. Thanks for watching.